All right, so let's look at the concept of supercritical fluids. Now, a supercritical fluid is a state of matter where the distinction between liquid and gas can no longer be made. And essentially, where a liquid and a gas kind of meets, um, if you want to see it like that. It has properties of gas, it has properties of liquid, um, but not really. It's not really either. So it can still dissolve something. For example, they use supercritical carbon dioxide as a very green solvent in organic synthesis because the moment that you no longer want the reaction to have a solvent, then you just evaporate the CO2, as an example. So those are things that you can use supercritical fluids for. But that's not the question here. The question here is, can methane or methane cannot be liquefied at room temperature, no matter how the pressure is, how high the pressure is. Propane, another simple hydrocarbon, has a critical pressure of 42 degrees, 42 atmosphere, and a critical temperature of 96 degrees Celsius. Can this compound be liquefied at room temperature? Explain. So what this means is um, the critical temperature indicates to us a point whereby we can no longer um, liquefy a gas. So you can see it as a point whereby this supercritical state starts to exist. So on a phase diagram, you have a point where you call it the critical point of a species, so C, and above that, temperature and pressure combination for a species, which in this case is 42 atmosphere and 96.7 degrees Celsius. Above that, the supercritical state exists, and you cannot dissociate or discern whether or not something is a liquid or a gas. Remember, this is a vapor curve, essentially, for your species. You just flip it around or whatever. Pressure, temperature, whatever you put on what axis. So, what you are looking for is it possible to then, at a lower temperature, liquefy it, liquefy this substance? And the answer is yes, because a gas can only be liquefied. So a gas can be liquefied, liquefied at T less than Tc. So less than its critical temperature. And at the moment, T is equal to room temperature, so that's about 20 degrees Celsius, and Tc is this 96.7 degrees Celsius. Okay, so basically what the question is we can apply enough pressure at this temperature to make the gas a liquid. If we were above 96.7 degrees Celsius, the average kinetic energy of the gas would have been too high to liquefy it. So at T below Tc, you can think of it as that the average kinetic energy, AVG, the average energy is small enough so that if we apply enough pressure, we will liquefy the gas. Right. So in principle, what it means visually is if you have a gas here, right? And this gas is at a certain temperature, and this temperature, given that it is below its so-called critical temperature, the gas, depending on the temperature, will have a specific amount of energy. Below the critical temperature, the gas molecules have little enough energy so that you can force them with pressure to come together to form a liquid. So then if the energy is small enough, we can force them together. So here we have gas, we apply enough pressure, force them together, and then we will form liquid. Okay, because the energy is low enough. If we are in a point where T is above Tc, or yeah, is above Tc, it means these gas molecules will have too much energy. So they will be resistant against any amount of pressure that we apply, and hence they will remain a gas, or well, meaning a supercritical state of matter, and they will not be able, we won't be able to apply any amount of pressure that will be sufficient to force them into a liquid state again. That's basically what this point here, this C point there, indicates, is that at any temperature above that point, no matter what pressure you want to apply, the pressure all of a sudden just shoots to essentially infinity, the temperature as well. So it's just a breakdown of the model. You can't do anything, and that's why it's called critical. So you can liquefy a gas, and what does it mean to liquefy a gas? It means that you apply pressure for the gas to go back into the liquid state. But above this temperature, you cannot do that with a gas. So if you have a gas at a specific temperature, there's no amount of pressure that you can apply at that temperature. You'll have to cool down the gas and then apply pressure, and then only you can liquefy the gas using pressure. So you understand, if you're above the critical temperature, you'll have to use temperature to liquefy the gas. Okay, so that's the idea of what supercritical fluids are in a supercritical state, and how you can manipulate temperature and pressure to get what you want. All right. This is more of an interest sake. It's not really that important. It's not an actual question that might ever be asked, but I think it's interesting nonetheless. I think a nice Google search or a few YouTube videos will be useful to watch on supercritical fluids. All right. Thank you for watching.